look,
रिकॉर्डिंग स्टार्ट कर सर जी।
if you look over here, the the horsepower, देखिए, let's say someone just asked that why don't we just say, the horsepower for 1, 2, 3 or 4 strands. We don't need that. देखिए, let's say if you go to that table and the horsepower capacity of a certain chain is 3, if you are using 2 strands of this, you will multiply this 3 by 1.7, which is K2. Because you see over here, for 2 strands it is 1.7. Theoretically speaking, it should be double because you are using double chain. It's almost a double chain, kana. Okay, but it is not the double of that, it is 1.7 times of that. Similarly, if you are using 3 strands, it is not going to be 3 times of that, but it is 2.5. So ये आपका K2 है. Okay, did you get the point now? So these are the number of strands, 4, 5, 6 and up to 8. You will
सर
multiply it
K1
by
कितने
the G.
K1 सर जी।
अच्छा, K1 तो हमने बात की ना कि let's say over here in the table, if you are the table only gives you the horsepower for 17 tooth sprocket. What if you are using 21 teeth sprocket? Then you have to multiply this by a K1. ठीक है जी. ये आपकी K1s है. This is K1 post extreme and pre extreme. Now, what is post extreme and pre extreme? देखिए, one is link limited and the other one is the roller limited. ठीक है जी. तो post extreme वाली जो entries हैं, those are the link plate limited entries. ठीक है जी. And you can use, it's just the way that they are calculating the horsepower or the performance. For post extreme आपकी जो entries हैं, those are the entries um, which are the one is link plate based and the other one is roller plate based. It's just the calculation of the fatigue strength of the roller chain through 2 different ways. ठीक है जी. Now going to the next, uh, जैसे ये है
सर जी,
इसमें जी जी.
सर जी हम लोग फिर कौन सा केवन यूज करेंगे,
You
पोस्ट
whatever
वगैरह
you
का यूज
use,
करेंगे?
whatever you use, as we said, कि आपके ये स्लाइड अगर आप देखें तो इट सेज फॉर अ सिंगल स्ट्रेट नॉमिनल पावर लिंक प्लेट लिमिटेड. सो दिस इज द लिंक प्लेट लिमिटेड वन एंड दिस इज द रोलर प्लेट लिमिटेड. ठीक है जी. But you are not going to use these equations. You are just going to get values from tables. Okay, so don't worry about these equations, these 2 equations. ठीक है जी. Now, one more thing. If you look at chains, chains have देखिए, chains have links. ठीक है जी. तो the chain length जो है, generally we would not say the length of a chain, but rather we will divide it by pitch, and that will give you the number of pitches. What is pitch? It is the distance from here to here. So basically it is the links. And we will specify the length in the number of pitches over here. So the length in pitches is given by this equation 17-34, and the center to center distance for chain is given to you by 17-35, where the value of a is given by 17-36. So you can use these directly. Now, um, if you have chain drives, as we said, that the allowable horsepower will be equal to K1 times K2 times H tab, and those two are the correction factors. Power that must be transmitted, which is the design horsepower. That is going to be H nominal, Ks, and D. And you get this from the, from the application. Now, the looking at the power, the design of of a chain. Let's see if we can find an example, and we'll go through that. Let's look at this example. It says that select a drive component for 2:1 reduction. ठीक है जी? 90 horsepower, input at 300 revolutions per minute, moderate shocks. This is for your KS. Abnormally long hour day, which is 18-hour day. Poor lubrication, cold temperature, and dirty surroundings. So the conditions are not really very good. Short drive, C by P is 25. The center to center distance divided by the pitch is 25. Okay? Now, let's see. What do you want from this drive, from this chain drive, is that it should transmit 90 horsepower, okay? And it should reduce the speed 2:1. If the speed the of one is 100, the other one should be 50. The sprocket should be 50. Okay? So let's see. The nominal horsepower is 90 horsepower. Okay? And speed N1, it's already given, that is your 30 revolutions per minute, and your C by P is 25. Let's take KS from I already showed you a table where you can find the service factor from. Since the conditions are not very good, so we will take 1.3. Okay? And the design factor, let's take that 1.5. And again, this depends on the designer, to what extent he wants to have the design factor, and the recommends the design factor. Now, let's say, for the sake of simplicity, since the tables are given to us for teeth of 17, why not take the first जो sprocket है? Let's take the number of teeth on the first sprocket to be 17 teeth. Okay, so now these are 17 teeth. For 17 teeth, you don't have to multiply it by K1, or K1 is 1, because the table is for 17 teeth. Okay, now um, what will be the number of teeth on the second sprocket? Since you are taking a reduction of 2:1, so it will be n1, n2 over n1 will be equal to 17, or rather I would say n2 will be equal to 17 multiplied by 2, which is 34 teeth. So the number of teeth on the second uh, sprocket will be 34. Okay? Now, also, if you go back to the table, if you use one single strain, K2 is 1. If you use double strain, it is K2. K2 is 1.7. Three strains, it is 2.5. For four strains, it is 3.3. Now, what is H tab equal to? Okay, we already said that what do you do in design? You will take H allowable and compare that to your H design. Okay, what is your H allowable? H allowable is equal to K1 times K2 times H tab, right? And that will be equal to your Ks and D, Ks and D times H nominal. ठीक है जी? Now, looking at this equation, can I look at H tab from here? H tab will be equal to Ks and D H nominal over K2 K1. ठीक है जी? Yeah, this is my equation now. Okay, so if I'm using 17 teeth, then my K1 is 1. So this will go away. This is going to go away. ठीक है जी? So I'll be left with this equation where I can put the value of Ks and D. I already know these. If you look over here, my ND is 1.5. So H tab is equal to 1.5 times ND, which is 1.3, the Ks, which is 1.3, times divided by, and my horsepower that I want to transmit is 90 H nominal and 1 and K2. Okay. So now,
एक्सक्यूज मी सर.
G
सर ये डिजाइन फैक्टर 1.5 आप दे दीजिए, अपने आप से लेने कि नहीं कोई टेबल से वैल्यू
table
लिए.
here. There is a this one, 1.5 is fine. 1.5 is a good value. It should be greater than, it should be greater than 1, and 1.5 for chains is fine.
और के एस के लिए सर वो
There
टेबल है
is a
वो जो
table,
पिछले
yes,
हमने यूज की
yes,
थी.
there is a table. Okay, okay, should I go ahead?
यस सर.
अच्छा जी, तो ये आपके पास H tab आ गया, right? 176 over K2. Now, देखें, the approach that we took over here is that we equated these two, right? And then we came up with this equation where we say that H tab is equal to 176 over K2. Now we are going to explore different options. Otherwise, you can choose a chain. You can just say, okay, I'm going to use this many strands. But with this equation, we can explore different options. For example, looking over here in this table, if I want to use a single strand, from table 17-3, for a single strand, my K2 is 1. So 176 over 1, that is going to be 176. And the chain, and looking at this, I can use a chain number 200 with lubrication type C dash. ठीक है जी? Similarly, if I want to use two strands, then it is 176 over 1.7, and that is 104. ठीक है जी? What is 104? That is the H tab that I'm going to look for. And for that, my chain number 160 can do that with lubrication type C. So these are the different options that I have now. ठीक है जी? Now these are the different options that I have. Now it depends on what lubrication type I want to use, and what kind of chain I want to use. um, देखें यहाँ पे, if I use over here, अगर आप देखें तो this is for 3 strands. ठीक है जी? For 3 strands, if I take 3 strands, then it is 70.4, and that is chain number 140. So let's use that. 3 strands of chain number 140, H tab is equal to 72.4 horsepower. ठीक है जी? तो I let's say the number of pitches in the chain will be, I have a formula for that कि LP कितने, what is L over P equal to, and if I do that, I get 75.79. ठीक है जी? But I cannot have these many, this should be an integer, so I'll go to the next number, which is 75.79 is almost equal to 76, or approximated to 76. So I can use a chain with 76 L over P. The center to center distance, again, I have an equation 17-35 for that. So I can 17-35 and 17-36. If I use that equation, I'll have the center to center distance equal to 25.104. ठीक है? And you will use the lubrication type that is specified for this is type B lubrication. Again,
Sir, excuse me.
I'm not saying that this is the final or the one and only design that you can have. You can choose another chain with other number of strands. ठीक है जी? other chain with other number of strands. It depends on you, right? So, and the lubrication type will also change with that. ठीक है जी? Um, not going through the exercise of
Solution.
hold on, not going through the exercise of exploring all these, you could have just straight gone to the table. ठीक है जी? और यहाँ पे जो आपके पास एच डिजाइन की वैल्यू आ रही है ना, व्हाट इज एच डिजाइन इक्वल टू फ्रॉम हियर? that will be 90 multiplied by 1.3 multiplied by 1.5. So whatever value you get from here, you can go to the table straight and see what chain number would you want to use for this design horsepower and what are the number of strands that you would use. So it is not necessary, but being an engineer, you can go and look at different chains that देखिए there are multiple chains that can transmit this horsepower. अगर हम इसको, if you want to calculate this, how much is this, does this come out to be? It's 90 multiplied by 1.3 multiplied by 1.5. So that is 175.5 horsepower. 175.5 horsepower. So now you can go to the table straight, and if you find a chain that can transmit this horsepower, you can choose it directly from there and say that this is my chain number. Or if you find something that would transmit, let's say for example, you would something that would transmit um, 50 horsepower. ठीक है जी? So how many strains of that will you use? It depends on the if I multiply this 50 by 2 times, that is going to be how much? 2 times अगर मैं करूं तो कितना हो जाएगा? Let's say you found a chain that can transmit 50. So multiplied by 2, that will become 100. You are still short of this. If I multiply this by, let's say for the number of four number of strands, मेरे पास what is K2 equal to for 4 strands? For 4 strands, K2 is equal to 3.3, and for अच्छा जी, so 3.3 say will it work if it is 50? It is, again it is 165. So let's say for 4 strands, if I use 5 strands, then for 5 strands it is 3.9. So probably that is going to work for me, because 50 multiplied by 3.9, that is going to transmit 195 horsepower. So up directly, you can also directly choose from the table. Okay, like because this is 175, right? So if I go to the table and choose a chain that can transmit 50 and multiply it by 3.9, where the number of strands will be 5 then. Okay? So that will transmit 195, which is more than 175. So I'm fine. Okay? जी, any question?
सर ये रिपीट करिए सर, इसकी समझ नहीं है सर, ये 50 के साथ आपने जो
अच्छा,
बताया
ठीक
क्या रहेगा?
ठीक है जी। मैं इस टेबल की बात कर रहा था। ठीक है जी, दिस इज just an exercise that we did to choose different options. For example, let's say you have to transmit, I said you have to transmit 50 horsepower, right? And you go to the table and there is an option that you can a chain number, let's say chain number 35 can transmit 40 horsepower. What would you do? And let's say that chain number 60 can transmit 60 horsepower. What are your options now? and you have to transmit 50. What are your options?
60
60
watt.
man.
Okay, not only 60. What if you
You
use, you can use two strains. They can, this is single strain of 60, but you can use two strains of 50 of 35. तो two strains के लिए आपके पास क्या रेशो है? It is 40 multiplied by 1.7 because K2 is 1.7. ठीक है जी, तो कितना हो जाएगा? How much will it be? 40 multiplied by 1.7, that is going to give us 68 horsepower.
68
ठीक है जी, so you can either use two strains of chain number 35 or you can use one strain of chain number 60. It depends on you which one you choose. So I'm saying that this is not the only solution. You can have different options. समझ आ गई बात की? Did you get my point? Any other question?
yes sir.
Any other question?
सर जी जो कमेंट में लिखा है,
जी,
ये कमेंट सेक्शन में जो लिखा है प्री एक्सट्रीम, तो इसका क्या मतलब है? एक पोस्ट एक्सट्रीम
हाँ,
होता
तो
है।
अभी हमने बात की ना प्री एक्सट्रीम और पोस्ट एक्सट्रीम की. It says this operation is on the pre-extreme portion of the power. So durability estimates other than 15,000 hours are not available given the poor condition life. देखें, ये प्री एक्सट्रीम और वो हम फिटीक के लिए कह रहे थे. ठीक है जी, जो आपको मैंने कहा रोलर बेस्ड एंड लिंक बेस्ड. ठीक है जी, तो इट्स जस्ट टॉकिंग अबाउट दैट कि इसकी लाइफ कितनी होगी. ठीक है जी, सो दैट्स इट. ठीक है जी. अच्छा जी, एनी अदर क्वेश्चन?